Hello and welcome to the section 3.3 lecture today for our Bridges geometry class. Today we're going to go ahead and look at some rotations, which is probably one of the harder reflections to visualize. I think it's not too bad to do, but in the visualization of things, I think it's a little bit harder. So let's jump right into it. We're going to look at three different rotations. And we're going to kind of have multiple ways to think about them. At least we're not necessarily going to follow the same verbiage as this graphic shows. There's a lot of reasons that I don't necessarily care about at this level to only consider a rotation in a single direction. So you'll notice here we have three rotations. We have 90 degree, 180 degree, and 270 degree. Basically, it's a rotation of three different right angles. It's one right angle for 90 degrees, two right angles for 180 degrees, and three right angles for 270 degrees. And it's always in this sense, it's always a rotation in a single direction, and that is counterclockwise. So a clock, if you don't see a clock on the wall or anything, a clock goes this direction, and it looks like we're going to have a bad pen video, but we're going to do our best. So this is the direction a clock moves. Any rotations, by how they define it, go the opposite direction of a clock. So they're all going to go counterclockwise. But I have no problem with saying a direction with it. The advantage to using the system that this graphic is using is that you don't have to give a direction of a rotation, you just have to give an amount. We're going to back that up a little bit and say that there's multiple ways that you can rotate. Sorry. So I'm always going to give you a direction with your rotation, and I'm probably never going to say 270 degrees because a 270 degree rotation is just a 90 degree rotation the other way. So I'm not a big fan of sticking to a certain direction of rotation because bigger numbers scare me, and if I don't have to deal with bigger numbers, why should I? So I'm almost always going to call this 90 degree rotation a 90 degree rotation counterclockwise. Okay, and you notice they say that in the instructions that it's a rotation of 90 degrees counterclockwise. So this one kind of holds true. Now, I will say in rotations, it's probably the first one that I really don't consider two ways to do it. I don't really look at just the moving the coordinate way. It's not that straightforward when I think about doing it. Now, I could probably say that if we were looking at an image and a pre-image of a rotation, that you could probably identify how far it's been rotated and what direction. I don't typically think about doing a rotation by I'm just going to visualize where it goes. Now, the other thing that I will say is that all of our rotations, it's not required in the grand scheme of transformations, but all of our rotations are going to be centered at the origin. We're going to rotate everything around the origin because it's a little bit easier. And it's the basis for any rotations. If you had a rotation that was around some other point, because you can rotate the entire pre-image around whatever point you want to, the basic strategy there is translate it to the center being at the origin, rotate it, then translate it back. So like if I wanted to rotate let's say I want to rotate around this point, not to get too deep into things. I'm going to rotate that triangle around that point. The basic strategy, even in higher levels of math, is to take this, move it to the origin, rotate it your 90 degrees. Maybe you want to rotate that first. Rotate it 90 degrees, and then move the origin back, and that's where it would end up. Okay, so we're just going to focus on rotations about the origin, because that's where everything needs to kind of start making sense. So I do mainly focus on the symbols, on the coordinate notation of what the coordinates turn into when I'm doing a rotation. So x, y will turn into the opposite of y, or I will say, probably incorrectly a lot, negative y, x. Just understand that when I say negative y, that could mean do a negative negative, which turns into a positive. Okay. So, to get a look at this one, a 90-degree rotation counterclockwise is going to turn 5-2. We switch the x and y, and we switch the sign on the new x, I guess. But again, I stick to those rules. That's something I'm going to carry through, and I'm just going to make a note so I can drag it through the rest of the page. 90-degree counterclockwise is, I'm not even going to write the xy. I'm just going to say it's going to turn into negative yx. Okay. For a 180-degree rotation, so that's just 2 rotations of 90 degrees, the point 5-2 goes to the point -5, -2, which is really just negative x, negative y is what xy turns into. Now, with 180 degrees, I don't need to give a direction because it's the same whether I go counterclockwise, as they say we always go, or if I decided to go clockwise 180 degrees, I'd end up at the same spot. Okay, so we're just going to make a note of that. 180 degrees is going to turn xy into negative x, negative y. The last one that we have is what they call a 270-degree rotation. What we'll probably see more often is it says that it's a 90-degree clockwise rotation. Okay, 90-degree clockwise rotation. It's going to turn 5-2 into 2 -5, which really just says that we, again, switch our x and y, but up here we made the first one its opposite on a counterclockwise. On a clockwise, we make the second one the second coordinate its opposite. Okay, so we'll say 90 degrees clockwise turns xy into y, negative x. And if you were with us in class, we talked about how you could make all of those rules based on, hold on, I gotta do this. There we go. You can make all those rules based on just continuing to rotate in a single direction and just reapplying the rule. I think it's important to understand how things kind of all work together. All right, so I've got my rules, and again, when I'm doing rotations, I almost always just use the coordinate adjustment technique. So with this first one, we want to rotate it 90 degrees clockwise. So we're focusing on this last rule that we have. I'm going to say what the points are and where they're going to move to. So we've got K at -5, -3. And that's going to get adjusted to switch them, and the new second one is its opposite. So switch them would become -3, -5. But I'm going to change this one to be its opposite. So -3, 5. I'm just going to go through and do them, and then I'll graph them all at the same time. L is at -5, -5. Switch them. The second one is its opposite. So we get -5, 5. And J is at -1, -5. So I'll switch them. Would be -5, -1, but I make the second one its opposite. So -5, 1. So let's see where this is going to end up. With a 90-degree clockwise rotation now, we should feel that that's going to go 90 degrees that way. We'll see if that looks like it's going to make sense. So -3, 5 for K, -3, 5, -5, 5, -5, 5, and -5, +1, -5, +1. A lot of times when I'm doing this, I will go ahead and get all the points out there, even graph, connect all the lines, and then I'll figure out where I can write the points so that they're out of the way. Write the labels so they're out of the way. So this one down here was J prime, this one was L prime, and this one was K prime. And yeah, that looks like a 90-degree rotation in the clockwise direction. The next one is going 180 degrees. So we have D, E, F, and G, just to go alphabetical, make some people a little happier. D is at -4, -1. Maybe I'll just get all the coordinates out there first. E is at -5, +3, -5, 3. F is at -3, 5. And G is at 0, 2. Okay, now we're doing a 180-degree rotation, so we want to follow that rule, which is XY turns into the opposite of the opposite of X and the opposite of Y. So I'm just changing signs on all my points. I'm not moving them to different spots. -4, -1 stays with the 4 first and the 1 second, and I just change the two signs. -5, 3 turns into 5, -3. -3, 5 turns into 3, -5. And 0, 2, the opposite of 0 is still 0, so that doesn't really change, but that becomes -2. So let's get these points out there. I've got 4, 1. I've got 5, -3. 3, -5. And 0, -2. And this was D, E, F, and G. And those all need to be prime. Need apostrophes on all those. Then I can go ahead and connect it, and there we go. That is a 180-degree rotation about the origin. I think I can move that down there and still have access to my rules. Let's go ahead and pull those down here too. It's a little bit easier for you. You probably don't need to write those because you can see the top of the page and the bottom at the same time, but I can't. For this one, we're rotating 90 degrees counterclockwise. So we're going to follow the first rule, but let's get our points out there. We have T, U, V, and W. T is at -1, 2. U is at -1, 4. V is at, looks like 4, 3. and W is at 1, -1. And again, we're following the top rule because we want to rotate it 90 degrees counterclockwise. So that's CCW on my notes there. So I switch the positions, and the new first one is its opposite. The new x coordinate is its opposite. So switching them would be 2, -1, but I want to switch the first one, so -2, -1. This would be 4, -1, but we want -4, -1. This would be 3, 4. We want -3, +4. And -1, 1 would turn into 1, 1. And again, we should feel like we're going 90 degrees this direction. That's what it should kind of look like. Okay, so let's go ahead and do these in order. -2, -1, -2, -1, -4, -1, -3, 4, and 1, 1. Okay, and that was T prime, U prime, V prime, and W prime. And then connect our shape. Missed it a little bit. And there we go. Let's get this last one done and call it good. I've got T, U, V, and W again. And I'm just going to put these on there before I really look at what we're doing. That's 3, 2. U is 2, 4. V is 0, 5. And W is 0, 4. Okay, and we are doing a 90-degree counterclockwise rotation, so that's the top rule that I have here, 90-degree counterclockwise. Switch them and make the new x-coordinate its opposite. So switch them would be 2, 3. We want -2, 3. Switch them would be 4, 2. We want -4, 2. Switch them would be 5, 0. We want -5, 0. And -4, 0. And again, it should feel like we're going this direction, and I believe it will. -2, 3. -4, 2. -5, 0. And -4, 0. So this one's looking right about there. And that is T prime, U prime, V prime, and W prime. Okay. So that is rotations about the origin. We got 3 different rotations that we'll focus on. If you've got any questions, make sure you ask me. Otherwise, I hope you have a great day, and we'll see you in class.